In this video, this is going to be our first example of logarithmic differentiation. And you're probably thinking, well, haven't we been doing derivatives of logs? Yes, but this actually refers to a technique of how to find the derivative of some gross functions. So what am I talking about? How about something kind of crazy like y equals x cosine x, right? How do I take the derivative of that? I know how to take the derivative of x to powers or e to powers, but I don't know what to do if I have x to a function. Okay, so as you'll notice in my notes for the course, the very first step that we're going to do in this process is we're actually going to take the ln of both sides. So I don't see any logs in this problem, so I'm going to put one in by taking the natural log of y and the natural log of x to the cosine x. All right, now you're probably wondering, why would you do this? Well, I agree, I am going to create a little bit of a mess over here on the left, but on the right, with log properties now, so not using any derivatives, but just using log properties, I can bring this cosine down in front, so now this will be cosine x times ln x, and I still have my ln of y. Okay, so first step in this process is to introduce a natural log. Second step is to use log properties on the right side to make it easier to play with. And the third step now is we're going to actually take the derivative with respect to x. So I'm going to write it over here so everybody can see that I'm taking the derivative with respect to x. So y is not an x, so this is going to be implicit differentiation on this side. So the natural log of x is 1 over x, so this will be 1 over y, and then I tag on a dy dx. On this side now, when I take the derivative of this side, I'm going to need to use the product rule because that's what's happening here is a product. So if I work a little bit to the side, the derivative of cosine is negative sine. The derivative of the ln is 1 over x. So it looks like I'm going to get cosine x over x minus sine times the ln. Nice and weird. Okay, we shouldn't expect anything cute. I mean, the original was weird. Okay, now, there's just two more steps that we're going to do. So the first thing is that I want dy dx by itself, so I need to cross multiply by a y. Okay. Okay, now, when we use implicit differentiation, when we have an original function that's mixed with x's and y's, then we expect a derivative with x's and y's. Our original was explicitly defined, y equals stuff in x. So we want to do the same courtesy and have our answer that way. So what our final step is that we're going to take this y, and we're going to replace it by x to the cosine x. All right, x to the cosine x. And this lovely thing is my answer. So that's how we find the derivative of x to the cosine x. I'm going to have a second example that is a different type of function, so make sure you watch the next video as well.